So this is my code for project 3 in the QLearner. So the first thing I did is I changed the constructor. I added the Q table here, which is a numpy array that defaults to 0, which is created using the zeros function, with the dimensions being the number of states by the number of actions. So with our test world, that would be 100 because we have a 10 by 10 grid, by 4 because we can move up, down, left, right. So a 100 by 4 table array, right? And then here we have also instance variables storing the values of alpha, gamma, epsilon, and the epsilon decay. And then, so then the next thing I changed was query set state. So I commented out the original randomization function and added this function here, right? So first we just create the action variable so that it's there to be read, and then we create this greed variable, which is a random number between 0 and 1. And then if that is less than the epsilon value, then that means we're going to explore. So I just pick a random possible action. But if it's greater than or equal to the epsilon value, then we'll exploit, which means we're going to take the highest possible Q value, right? Using this Q for the current state, the highest one, and then we get the action, which is the argmax. And then we set the current state as the new state and the current action as the action we decided upon, and then also return that action to be used by the calling function. And then for query, it's very similar. The main difference here is that we also add this section here at the top where we change the value of the current state action combination based on, the value of the previous combination using this 1 minus self alpha times the Q of S and A. And then we also use the new stuff by getting alpha times the reward plus the gamma times S prime, which is our new state, the max Q value for S prime, which is the new state. Other than that, we use the same method here also, except with the addition of this line here, where we're essentially decaying the epsilon value by our decay value to a minimum value of 0.01, just so that there is still a little bit of randomization, even if it takes, many, many steps to solve the algorithm. And then that's pretty much it. Then you can just run the tester. I already ran it because it takes quite a while to run through the whole thing. But as you can see here, my implemented learner for world 1 takes about 233 steps, while the template, which is purely random, takes 400 steps. For world 2, my implementation takes 88 steps, while the template takes 3,775 steps. And as you can see for all of the other things, it's similarly much more efficient, which shows that my QLearner algorithm is, working properly and is much more efficient than the other, the other program, the initial QLearner, which is purely randomized. So as you can see, it's way more efficient, does it in much less steps. It's able to find the exit in many less steps compared to the randomization. So as you can see, it works quite well.